Okay, the next problem in the exam is we're given this assembly function. We have to write an equivalency function given the following prototype. That is, we assume the function takes in an integer called n and returns an integer. And again, both are going to be in R0 as the calling convention states. Okay, so what am I going to do? I'm basically going to look at the assembly code and see what variables I should define. So what does foo do? Well, the first thing it does is move a 0 into R1. So what I might do is declare a new integer. I might call it x. It doesn't matter what you call it. And I'll assign it the value of 0. And then I put a 1 into R2. So I'll declare another variable y, and it can be 1. Okay, and then we've got some sort of loop going on here. What's this loop doing? So we add R1 and R2, store it in R2. And then I take R2, subtract R1, put in R1. I decrement R0, which is my input. And then if it's not equal to 0, that's a typo there. Whoops, that's refoo loop. If it's not equal to 0, do it again. Okay? So it looks like regardless of whether or not the condition is true, we always run the code once. So there's a few ways you can implement this. You could try and work out what this is doing. So it looks like it runs the code and it's counting down to 0. But it always runs at least once. So I might write this as a while true loop, and then I'll have a condition to when to bail out of the loop. So that way it's always guaranteed to run the code at least once. So while 1, because 1 acts like true in C. So I do this code. So I forgot my variables. So this was R1, and this was R2. So I guess the first line translates as x plus y, and then store it in y. Okay. And then y minus x, and then store it in x. And then I have to check my condition. So then I subtract 1 from R0, which was n. Okay, so n equals n minus 1. And then if n is not 0, run the loop again. So if n is 0, bail out of the loop. So if n is 0, break out of the loop. And then what do we do at the end of the loop? Move R1 into R0, and then BXLR. So it looks like it's returning the value in R1, which is x. So I'll just do that directly. Return x. Okay. So I think this is doing the same thing. Sanity test. You could run the assembly code and then run the C code on a particularly large input, maybe 10 or so, and check if they do the same thing. So I might copy this code, cheat a little bit. So I'll uncomment it, and then I'll just steal it and put it inside the main function. So main.s, I'll just dump this here at the bottom. So there we go. I have to write the boilerplate to make the compiler happy. So size foo, comma, dot minus foo. And then we have to declare foo's thankfully that's already done for us. So foo's a function. And then it's going to get upset because we called it the same thing, so I better call my foo something else. I'll call it foo2 loop foo done, and put 2's everywhere. There we go. And then I'll BL to foo with a 10 as an input. And then I'll do the same thing again. And then I'll BL to the foo function written in C, which is just called foo. And I better comment this back out again because it's not going to compile. There we go. Okay, so let's run this in the debugger and see what happens. Go to debug. Oops. Probably want to set a breakpoint at main so we can actually step through it. So let's try that again. All right. Yep. Debugger's being unhappy today. Give that another go. Okay, cool. So we move a 10 into R0. So R0 contains 10. Let's move all this other junk out of the way. So here we've got R0 10. I call the foo function. Let's just step over it. And so this is my assembly version down here. And that puts a 55 in R0. Hopefully the C version does the same. And, well, let's just step out of this function. I don't want to be here. Let's just let that run. And it too puts a 55 in R0. So both functions do the same thing with R0 equals 10. So that should give me at least some confidence that I've correctly converted the assembly to C, because they at least seem to match for a single input. If you wanted to be a bit more rigorous, you could write a loop in main and just test that they match for a bunch of inputs. So you could very easily write, have some sort of loop. What could you do? So loop mov R0, 1, BL foo, which return a number in R0. So in fact, we might want to back that up on the stack. So push R0. And then we'll have a number in R0. And then I'll, what am I going to do? I want to check if both functions return the same thing. So because both functions take inputs in R0, it's going to be a little bit tedious. So what we could do is we could have a counter in maybe a different register, maybe R4. I could move it into R0, call the function. So we call foo2. That gives an output in R0, which I'll push on the stack for the moment. And then I will move R4 into R0 again. And then call the other version of the foo function. And then the output of that is in R0. So I pop the result from the previous function R1, and then I can compare if R0 and R1 are the same. And if they're not, go to, bad or whatever. So it didn't match. And if they did, try the loop again after adding 1 to R4. So add R4, 1, and then we'll initialize R4 to 1 at the start. There we go. And then didn't match. Would just be like an infinite loop. Nope. B didn't match. And this is sort of a clunky way to get it to loop and check that both functions return the same thing. So there we go. So I can try debug this and then just let it run for a handful of inputs. And if it works a bunch, I should be pretty confident I've correctly converted the C into assembly. So I'll just put a breakpoint here. So we step through. R4 is 1. Run the code once. I don't want to be here. Let's just get out of there. They seem to match. Run it again. Run it again. I don't know why I keep breakpointing here. Let's get rid of that breakpoint. We don't need that. There we go. And so I just keep running it, and R4 here is getting bigger and bigger and bigger. And because I never get to the didn't match function, it looks like these functions are agreeing for most inputs. In fact, if you look at the registers, you might recognize this is actually the Fibonacci sequence, which is actually what the foo function is doing. So this can be a good way to test that your function is doing the same thing as what the C function does, or as what the assembly function does, by just writing a loop and checking it for a bunch of different values. And that can give you some confidence it's doing the right thing.